Section 12.4, angle measures and segment lengths. So there's a lot of different things we have to find in this. A new term, we have secant lines. These are lines that intersect the circle at 2 points. So if we go through this picture, this one is obviously a tangent line. We had these before. It touches the circle in 1 point. This line right here is a secant line. And when you get to trig, you'll understand more what a secant is. This line right here is also a secant line. For us, it's just a line that crosses the circle twice, and then they do some other things. Alright, so Theorem 1211 has two parts. First part, you have two secant lines that cross inside the circle. So you may want to write yourself a little note here that says inside, because that's where they cross. The other part of the theorem crosses outside. So if I want to know the measure of this angle right here, angle AED, it is half of the two arcs that it creates. So it is half of this arc and this arc. Okay, so we add those two arcs together and we take half, and that gives us the measure of this angle in here. And then obviously by vertical angles, we could get the other angle across from it. Okay, so that's part one. Part two is when the two secant lines cross outside. So you may want to write outside for that. So this angle out here, you take the bigger angle minus the smaller angle and take half of it. And that gives you the measure of the angle outside. Okay, so let's try a couple. So this one, the lines cross inside, so that means we add the two arcs and take half. So 46 plus 90 is 136, and half of 136 is 68 degrees. So then this angle is 68 degrees, that means this angle is also 68 degrees. Alright, this one, they cross outside, but you notice that z is one of the arcs, so we have to kind of solve an equation for this. So we would take the big arc minus the small arc over 2, and that would give us 20 if we did our answer correctly. Okay, so we have to work backwards a little bit here to figure this out. So I would multiply both sides by 2 to start, to get rid of the 2. So I've got 95 minus z equals 40. And then I need to know what z is so that I can get 40. So z has to be 55 degrees. Okay? Big arc minus small arc divided by 2 gives you the angle on the outside. Alright, this one, you could use a little detective work here. We know a circle is 360 degrees. We've got 110 from this dot to this dot, so that means there has to be 250 degrees in the rest of the circle. Alright, crosses outside, so we take big arc minus small arc over 2. So 110 minus 30 is 80, divide by 2, 40 degrees. Okay, now this theorem, you need to pay particular attention to the pictures, and you're going to match the pictures to whatever problem you're working on and set it up from there. Okay, so you've got a case 1, a case 2, a case 3. Case 1, the two secant lines, so we'll put case 1, it's two secant lines, and they cross inside the circle. Okay, you set up almost like a proportion. You do one piece times the other piece on one line, and that equals one piece times the other piece on the second line. Okay? Case number 2. This is two secant lines, and they cross outside the circle this time instead of inside. So this equation reads the length of the whole line, so w plus x times the piece on the outside equals y plus z, the whole segment, times the piece on the outside. Okay, that's why I said you got to follow the picture. And then case number 3, this is a secant and a tangent line, because T is a tangent line here. Okay, so you take the secant part from part 2, so you do the whole line times the piece outside, and that equals the piece of the tangent line squared. These take a little bit of practice to get good at. So, for this one, this is a case 2 because it's 2 secant lines and they're crossing outside the circle. So, we go the full line, so that would be 6 plus 8 times the piece on the outside, which is 6. And then the other one we do the same thing. So, the whole secant line, 7 plus y, times the piece on the outside. And then we do algebra and we start cleaning it up. So 6 plus 8 is 14. 14 times 6 is 84. So the whole left side simplifies to 84. Over here, we have to distribute. So we have 49 plus 7y. And then we start doing some math. So we'll subtract 49 from both sides. We get 35 equals 7y. And then divide by 7. We got y equals 5. Alright, this one, this is a case 3 because it has a tangent line and a secant line. So we do the whole secant times the piece on the outside equals tangent squared. Alright, and we start doing some math. So 16 plus 8 is 24 times 8 is 192 equals z squared. And then we're so good at this, we know what we're doing. So you have to take the square root to get rid of the square. So square root of 192 is 8 root 3, which is 13.9. Alright, this one is a case number 2 because it's 2 secants and they meet outside. So we do whole secant times the piece on the outside, and then whole secant times the piece on the outside. So 20 plus 14 is 34 times 14 gives us 476. Over here you have to distribute. And then we need to solve, so we're going to subtract 256 from both sides. And divide by 16. And we get 13.8 if we round to the nearest tenth, like they said up here. Alright, one more. This one, this is a case number 1. That's 2 secant lines, but they cross inside the circle. So we do one piece times the other piece on one line, and then one piece times the other piece on the other line. So we have 6.5 m equals 21. Divide both sides by 6.5. We get 3.2 to the nearest tenth. Okay, good luck.